Large volumes of government capital are moving out of centralized banking institutions and flowing into decentralized rural communities. In southern Thailand, women's development groups act as the primary economic engines for this capital, managing zero-interest government loans to build local livelihoods. These groups often track these funds using analog methods, physical notebooks filled with handwritten ledgers and manual calculations that frequently introduce errors. While off-the-shelf financial software seems like an obvious solution, standard fintech dashboards overwhelm these users with complex interfaces designed for professionals. Distributing community capital without providing accessible management tools creates a risk of default, threatening the economic stability of the entire region. Modern financial software is built on two specific assumptions: that the user understands accounting principles and possesses high digital literacy. In rural environments, these assumptions cause the software to fail, as feature-rich dashboards become impenetrable walls of text. Designing for this demographic requires adhering to three strict constraints: managing zero-interest debt, accommodating low digital literacy, and requiring zero background in accounting. The Pay-Sure mobile application was engineered specifically to operate within these three constraints, discarding standard financial tools. Achieving digital financial inclusion requires abandoning comprehensive software suites in favor of mapping user-centered design directly to behavioral psychology. To build field-ready software, developers rely on the ADDI model: analysis, design, development, implementation, and evaluation. The design phase is the critical bottleneck where standard fintech applications lose rural users. The solution involves anchoring user-centered design, UCD, directly to this phase. In this context, UCD dictates that the software's architecture is shaped entirely by the user's real-world literacy limitations. During the initial analysis phase, researchers found these users needed a systematic way to track community debt rather than complex investment modeling. Iterative prototype testing then stripped away standard accounting jargon that typically intimidates the target demographic. Integrating UCD into the ADDI model creates a pipeline where user constraints, not developer habits, dictate the final software architecture. The resulting application operates with extreme limitation, relying on only 4 core functions. The investment recording interface lacks complex fields like asset depreciation. UX choices minimize manual data entry, like this visual calendar. The income screen replaces jargon with simple terminology and massive touch targets. Finally, financial reports present critical liquidity metrics through a simple bar chart. Developers deliberately omitted forward-facing debt-to-income calculators to keep new users from feeling overwhelmed during early adoption. This visual minimalism hides complex accounting mechanics behind a frictionless facade. The success of this interface is measured using the technology acceptance model, which predicts whether a community will adopt a new digital tool. For cohorts with low digital literacy, perceived ease of use is the dominant variable dictating success. When an application is perceived as easy to use, it increases the user's perceived behavioral control over the task. According to the theory of planned behavior, when a user feels in control of the software, their attitude toward the financial task shifts. That attitude shift translates into consistent, real-world financial planning. In grassroots fintech, UI design is a calculated psychological lever used to build financial discipline. This methodology was tested during a rollout to local women's groups in Yala province. Evaluated against ISO IEC 25010 standards, this data table shows the minimalist UI did not compromise system stability, scoring 4.57 for functional suitability and 4.63 for performance efficiency. User acceptance testing returned high marks in this second data table, with 4.66 for perceived usefulness and 4.55 on the system usability scale. Qualitative interviews revealed that initial adoption barriers were related to general digital unfamiliarity rather than friction within the software. Community peer support rapidly overcame those digital hurdles, as the interface did not require formal training. The quantitative data proves that an aggressively user-centric approach yields significant software acceptance in demographics with low literacy. The Pay-Sure application provides a replicable engineering model for grassroots development. This methodology offers a solution for similar economic environments across Southeast Asia. Global financial inclusion initiatives often fail by forcing complex, top-down software onto users, requiring extensive training. This research proves the necessity of engineering software that adapts to the technical realities of the grassroots user. Bridging the digital literacy gap requires deploying engineering blueprints that prioritize localized simplicity.